Hello friends, welcome back to the bench. Today we're going to take a look at a power washer or the pressure washer. It broke and I figured as long as there's something electrically wrong with it, I can fix it. I can really fix the actual, motor inside, or maybe I could take a look, but I have a very basic idea of how it works. I have no experience working with high pressures. This is like 1000 psi pressure, rated up to 3000 psi, but obviously never gets that high. But on the plug, right, I have a cover over here. You have this big plug on which you have reset and test button, right? And what's in it is basically a switch, a electromagnetic switch, a relay basically, which basically will disconnect the load, right? And that's pretty much what it was doing. You hit reset, but nothing happens. The device doesn't turn on. So I removed it. I replaced it with the regular plug, and the power washer or the pressure washer was working just fine. But I figured, let's see what happened with this thing. And as I was disassembling it, there's seals on top of seals, and this should be sealed. This should be, the buttons also are, the buttons that you expect to be watertight, and that's how it was designed, to be watertight. But take a look at this, plenty of corrosion. Now take a look at the actual device, right? Plenty of corrosion. So this turns out not to be sealed, and that is probably the problem. The device itself was kept, well, not exactly in the place where there's not enough, where there's no humidity. Quite to the contrary, it was very humid. But who would expect that, the pressure washer is not gonna like water? It's kind of the principle they work on. They just pressurize water, so they should be sealed. This one is not, but that doesn't really tell us much. How it works is actually extremely simple. There are two contacts here, one over here and the other one over here, and basically it just connects these two to these two. There is a little coil over here that I assume detects how much current is flowing through these wires, and if it's too high, it disconnects. And perhaps it detects some back EMF, or I don't know, some kind of interference, or maybe it's capable of determining whether the motor on the device is faulty, and maybe uneven load or something like that, and in which case it also disconnects. It could be sophisticated. Let's take a look at it under the scope. And let's see our contacts. This is contact number 1, right? And I can trigger it with my finger, right? And contact number 2. I did not hear anything. Here, contact number 2. I didn't hear any clicking when hitting reset. It has a significant click to it. So you would hear if it turns on. It wouldn't. So I went ahead and just started measuring stuff that is easy to measure. basically resistors, looking for shorts, shorted caps, shorted transistors. There's two, no, actually just one IC that seems to be controlling this. It's this one. It says, let's see, can we read it? CL, yes, CL. CO 4145. 4145. That to me sounds like a regular TTL, you know, some logic gate based on the symbol, but it could be anything. It could be something more sophisticated. This looks like a transistor, and also there's no short on it, and it's 1N60G. So that's definitely a transistor. What caught my attention, because obviously, I'll take a look at this. There's a huge corrosion over here, right? These are likely, yeah, capacitor. And what is this? This is resistor over here. So if that resistor is not working, that could explain why the device is not working. No, you can probably still read the value of it. That's good. I see a big 2 on it. But this one, this is 15K resistor, right? It actually connects to that coil, or as far as I could see, yeah, this little wire here. And well, and it goes somewhere further to the circuitry over here through this via. It looks like the board is more than just two-sided. It looks like it's multi-layer. I'm not sure, but I do believe that there is one more layer inside. So it's going to be kind of tough to reverse engineer this one or retrace. Not impossible, but definitely not worth it. But as I was measuring this one, let's go into the resistance mode. Yeah, and open line, right? Nothing. But the resistor itself, if I touch just the resistor leads, I got 15K, right? 14.7. So this resistor is definitely not making connection over here, which is weird because this one actually is not suffering from too much of the liquid damage. And this will be probably the same case over here, and likely with these. I think I checked this one as well and it had the same issue. Yeah, so the board is not making connection with the components. Yeah, component itself is reporting. This is 47K and we have 47K. The resistor is fine, but it's not making connection. So pretty much this will be the issue with this device. Nothing more to it. It's just corrosion got into it, which is kind of surprising because you would expect these devices to kind of withstand, or at least be sealed enough to withstand humidity. Because obviously, you know, the cable, the pressure cable or pressure you know, pipe that goes into the handle, the wand, it's not that long, right? So your actual device is going to be relatively close to you when you're blasting pressure. So obviously it's going to get wet. And you might argue that the plug is going to be somewhere where it's dry, and the cable is relatively long, but still, you know, then you just kind of wrap it up and you keep it with your wet device. So that's kind of weird that this is not sealed. But what are we gonna do with this one? Just for the sake of satisfying my curiosity. I'll put it in the ultrasonic cleaner for a while, and hopefully this will remove all the corrosion that I see over here, so I can see the actual components. Then I will reflow components on it, and testing it is actually extremely easy. I don't even have to connect the load. If I connect it and I hit the test or the reset, it should click, and if it does, then you know it's working, because it looks extremely simple. I want to look into this little chip over here, but my guess is that this is just some simple logic gates, nothing more to it. There's very few discrete components. It's very simple, which is why I like it. I like simplicity. I like simple circuits, especially simple repairable circuits. As far as repairability of this one, it's pretty good. So no components have removed markings. The board has markings, no actual values, that would be even better, but it has markings for the resistors, capacitors, and all that. And so this is repairable. So this is what I like to see. Now let's throw it in ultrasonic cleaner and see what's gonna happen. All right, after cleaning, it actually looks not too bad. This is the resistor there. I was not making good contact. Right, this side of the board is not too bad. This is the resistor we couldn't read because it was so corroded, and we still can't really read it, but that's because the soldering on it, and still some corrosion left on it. That's fine. Here everything looks semi-good. Here we have some corrosion, and here we have some corrosion. No biggie. Reset button. 0 ohm resistors. This side actually looks pretty good. A transistor. I could not find a data sheet for this chip. So let's just reflow it. Let's get some tiny solder. Let's get some cheap flux, or old flux. Oops. Oopsie. In there. We'll get some Antec. That's a nice, no clean flux. Oh. Okay. And now let's blast it with some hot air. Let's give it 390 at 50 liters per minute. Meanwhile, let's figure out, because this is my light bulb, and I do want to connect it through the light bulb, but this is made for different kind of devices. So I need to get I need to get a converter. Actually, that will be the easiest thing. Okay, it works. So this is off, so let's connect it. There. And there's still plenty of flux left over, but that's fine. So now when I turn it on, before I turn it on, I need to make sure there's no short on these. And there. And if I hit reset, it should turn on. It does not turn on. So we have an actual malfunction on it. So the liquid damage, the corrosion, was unrelated. Something else is wrong. And for me to figure out what's wrong with it, I would have to know what this little chip is, how it works, how it actually controls it. Then I could verify whether the chip itself is okay. I checked all the discrete components, so that's what I could do, and all of them are testing fine. I redid the connections and everything looks good. So likely, yeah, because I doubt it's the transistor, but it could be. But usually when they break, they just go short. Yeah, it looks like I'm not gonna be able to repair this. Well, you can't win them all. If you're interested, send me your address. I'll send it to you if you want to give it a shot. Be my guest. But for now, I deem this no repair, no fix, no fee. Well, the washer itself is working, so yeah, no, that was a good try. Unfortunately, no success. But at least now we know how it works. I always wondered what was inside these little sockets, these little plugs. How this actually protect the circuit. Well, it is fascinating device. Maybe I can learn a little bit more about how it actually works. Because it's my first time looking at this actually, so. Alright, well, nice try. No fix. I hope you at least found it at least a little bit entertaining. Other than that, there's very little value in this video. But I thank you for watching anyways, and I shall see you guys in the next one.
Black Horse Repairs, subscribe. You heard me.